Good evening, students. Now, today we shall discuss one more numerical. This I've selected from gate exercise. So let's see what does this numerical say. Three-phase 60 Hz, 500 MVA, 13.8 kV, four-pole steam turbine generating unit has an H constant equals to 5. The unit of H is, again we know, a megajoules per MVA. This we had discussed in our classes, and in previous YouTube content also I had told you what is H, inertia constant. Determine the mechanical angular acceleration alpha m if the unit is operating at synchronous speed with an acceleration power of 500 megawatt. You see, the manner in which I selected the approach of the numerical, first G is given 500 MVA. 500 MVA is your machine rating. So G is equals to 500 MVA. And inertia constant H is given 5 megajoules per MVA. So from there we can calculate our angular momentum M, which is equals to GH by 180F. So G is your 500 and H is your 5 and frequency is your 60, there is F. So from there we get M equals to 0.2315 megajoule second per electrical degree. Now acceleration power is given in the numerical just at the end 500 megawatt. So PAG is equals to 500 megawatt. Now we know that the acceleration power PAG is always the product between angular momentum and your angular acceleration. So from there is PAG is equals to M into alpha. M is your angular momentum and alpha is your angular acceleration. Therefore from here we can get our angular acceleration, that is alpha, which is equals to PAG by M. So substitute in place of PAG, that is 500, and in place of M 0.2315. So you will get your alpha, that is 2160 electrical degree per second square. But the question has asked that you have to calculate, that is determine the mechanical angular acceleration alpha m. So one numerical I had given in the Google Classroom. There I had discussed this type of numerical. So formula is short, but these kinds of very tricky questions can come. But if you know the formula, within seconds it can be solved. So if you are asked to find out your mechanical angular acceleration, then always remember that mechanical angular acceleration, that is alpha m, is equal to alpha. This alpha is your angular acceleration in electrical terms. Okay, so alpha m is equals to alpha divided by pair of poles. Okay, now in this numerical they are saying that there is a steam turbine generating unit, but it is of 4-pole. 4-pole means there will be two pairs of poles, isn't it? North south. So there will be 2 pairs of poles. So pair of poles is equals to 2 and alpha is 2160. So alpha m becomes equals to 1080 mechanical degree per second square. Thank you.